Hello everyone, my name is Himanshu Singh, and today in this particular video we are going to majorly talk about the large language model. And when I say large language model, like whatever the open source or API based large language models are present in the market, and what are the different use cases are there for these LLMs, and how can we use it. Apart from that, what is the backbone of these LLMs, right, which is a transformer. So this is all we are going to talk about in this particular video. So mostly we will be trying to cover this all the theory part of this LLMs, and then in the next coming video we will be talking about the code part, right? So before going to the large language model, we should be understanding what is language model, right? So when we say language model, it means the model is somewhere working on the completion of the text, right? Language, you have the text data, right? You have the text data. You are having, let's say here, can you please come here? So means what will happen? Your model will try to predict the next word here. This is what the difference between a traditional and a large language or language models. So language model will work with the textual data, and it will try to predict the next word by giving the context itself to the model, right? So let's say here in this particular example, can you please come? Okay, this is my context, and what should be the next word? That is my predicted word, and that predicted word will be given by your language model, right? Where are we? Dash dash. So it means going, or there can be more words. Next, this predicted word will be predicted by the large language model or language model in terms of, right? Next, the backend is same, right? Probability of word of n means whatever the probability of n, like whatever the coming word is, what is the probability of getting that particular predicted word n will be dependent on the word 1, word 2, word 3, word 4. Means what should be the probability of going with respect to this is kind of probability based on the conditions, like this one is given already. Where are we going? So word 1 will be the where, and word 2, word 3, like this is a base version. When we say somewhere you have heard of Naive Bayes algorithm, base, right? Base theorem maybe you have heard of. So this is a based on that is called the language model. But when we talk about the large language model, there's word called large means there is something, whole architecture is being converted into the state of art models, right? So what is happening here we are using the transformer architecture. So now what is transformer? Actually, whatever the LLMs are there, all the LLMs are being built on the transformer architecture. When I say transformer, it means you have two architecture, two combination, or you can say two modules combination, right? So first part is your encoder, right? And the second part is your decoder, this one, right? So if I zoom in here, what is happening in the encoder part, when you give your input here from this particular point, input will be converted into input embedding, and then there will be a positional encoding for each particular words, then multi-head attention, which is a backbone of transformer, then adding a normalization, feed forward network, and adding normalization. So what's happening? Encoder will encode your textual data into some particular vector space or something, right? Like that. And then this particular encoder's output will go to the decoder part here. Again, multi-head attention is here, add normalization is there, and feed forward network is there. So this is how it is happening. One word will be go inside this encoder, and it will be decoded by encoder will encode your word, and decoder will decode it like this. Let me just show you one very good blog here, which is from the JLMR, right? He has written this blog very beautifully. Actually, the transformer architecture he has defined is out of level, right? If you see like machine translation only, you have the transformer, you have this particular input. I think this is on a German language or French, I'm not sure about that, but let's say this particular language is again, right? You have to translate into the English word, right? So this is how, if you give this to the transformer model, it will give you this kind of output, right? here also. And in the back end, the transformer is nothing. It's an encoder and decoder model itself. Here encoder and decoder. So before, I'm not going to talk about this transformer briefly on this particular video. I would suggest I'll share this link of the blog on the description. You can go ahead and look into this blog. This is very beautiful actually. If you go one by one, you'll able to clear all your basics, right? But I'm going to give you the most important thing, how this transformer is working, how these all the models are working. Yeah, if you see here, all the words has been encoded, right? This word has been given to encoder and it got encoded into key and value vector. And now if you see this, each word will go one by one, right? So I have went here and I will be encoded to I, then M come here, right? And M will again go, right, to the decoder. So what's happening? Yeah, if you see here, right? So M is going to the decoder. Also, this value vector is also going. So both will be concatenated and this will be translated, right? So what's happening? Decoder will take the input, current input, as well as the previous output, n minus 1th time output. Both it will take and it will produce the next word, right? Whether it is doing translation, whether it is doing generation, in all kind of steps, it is doing the same thing, right? This is how this transformer model work. And the same way your GPT or BERT also work. Like if I talk about the GPT-4, GPT 3.5 or any other models, the same, these generation models are somewhere built on top of the decoder only. If you stack decoders one after other, this will call the GPT architecture. If you stack your encoder architecture, this one again and again, like 4, 5, 10, so it would be a BERT architecture. So these BERT and GPT has been inspired or built on top of the transformer. Decoder will be your GPT and encoder will be your BERT models, right? Like this, in a simple term, if you say. So if I talk about the conclusion of this one, right, large language models have the backbone as this transformer. They are using this transformer as a backbone, right? Anyone, if you talk about, then they are very powerful because of their power to guess the next word, to generate the next word. They have been a very good knowledge base, which because of they have been trained a very massive amount of data itself, whether it is whatever is present on your internet itself, like whether it is blog, videos, audios, pictures, everything, right? Now the next thing comes out here, like, okay, we know about this large language model, right? But how can we use it? How can we utilize these large language models? So there is two ways always to use that. In earlier videos also I have talked about this. There would be a API and there would be an open source model. So you can use these models as an API. So if I talk about the models which are present as an API, like OpenAI's all the models are present as an API. Mixtral model, Mixtral 7B, Mixtral 8x 7B, right? Microsoft Azure or Amazon Bedrock also providing the different models, and their Mixtral models and other open source models are also there. Grok APIs are there together. Like Anthropic Cloud 8 is doing very well, right? Nvidia is having their Nemo framework, right? All the models are present there. Google Perplexity is there, right? So different platforms are there, different models are there itself. You can go there, you can create your own API and you can use it, right? This is what called you are using model as an API. So you do not need to worry about the infrastructure, the deployment, the scaling. You just need to pay as you use. So this is very important to understand right now. The word like you have to pay the way you will be using it, right? So how it is happening actually? Let's say if I'm having kind of this pay is dependent on how much you are using. Specifically, if I talk about this OpenAI, all the models are based on the tokens itself. Let's say if I talk about a problem statement where you need to translate this particular document, right? So just wanted to show you that. That's why I'm taking this particular only this particular chunk of data. So let's say if I give this particular data to OpenAI API or any particular API, LLM API, so how much cost I would be getting? That is what I'm going to calculate. So first let's find out how many tokens are there in this particular chunk itself, right? So we have the OpenAI's platform, OpenAI tokenizer. So if you paste here, you will able to get right what is the total number of tokens present. 173. In English word, we have total of 173 tokens present in this particular chunk. So what is token? Token is nothing. It's a it's a same, you can say, a word length or something like 4 or 5 character can make a one token itself, right? So this is dependent on the different models itself. Like model is considering sometimes 5 characters a token, or 10 characters or 7 characters as a token, right? So for GPT case, they are considering around 4 to 5 characters as a one token itself, right? So 170 tokens are there, 173 tokens are there as an input token. So when I am writing my model that you need to transform or translate this particular text into the into German or French, right, from English, so you are adding some prompt as well, right? So what will happen, there would be some more tokens in the prompt. So let's say 10 tokens I am taking, or 20 tokens, or let's say 25 only, or so it can be roughly, I can take it as a 200 token prompt plus input this text. So I'm having input as a 200 token, and output I can consider for German, let's say 170. Okay. Now this is a very good platform, GPT for work. So you can go here, you can select your tokens, word or something characters from here. You can write your input token. So I'm having total 200 input tokens. Output I'm taking like 150 around. Okay. Number of API call, only one API call I'll be giving, and I'll be getting my response. So input token, you understood, input text or context plus prompt, that would be input token. Output token means whatever the rewritten object or rewritten content LLM is providing to me, that is output token. What is context window? So context window will be my input plus output token. So context window in this particular case, it would be 350, right? Number of API call is 1. So now if I calculate it, if you see here, this is how I'm getting. So for GPT-4o, I'm getting very less charges, somewhere near to 0.32 something like that, because it's GPT-4 is very less costly, right? GPT-4o mini, I'm getting 0.001 something like that. GPT-4o turbo, very less. So let's consider it for the 2000 to make it more better, and 1500 for this one. So in that case, if you have 2000, means right now you're considering this chunk. This is having 200 tokens. Now I'm considering 2000 tokens, and for 2000 token, I'm getting around, and it is context is somewhere 3500. I'm getting for GPT-4o, I'm getting $0.03. For GPT-4o mini is very cheap, right? For GPT turbo 0.7. For GPT-4 it is more. GPT-4 is more, right? $0.15. Or if you see for Google also, it is given, Cloud also, Sonnet also, right? This Mixtral large models also it is given, right? So it's very good platform, guys. If you want to do a kind of cost estimation for your project or for any particular work, please do visit. I'll paste this link of this particular platform on the description. You can go ahead and look into that. It will help you to understand the costing, understand how much your project would be needing, right, based on that itself. And it's very cheap, right, in case of API call. All or most of the models are there itself, so you can able to calculate it, right? I hope it is clear. Now next part we have open source. So let's say if you have open source model like Llama 2, Mixtral models, Falcon models, MPT or Bloom, or any kind of model, what will happen in that case? In that case, we have to download these models from the Hugging Face or somewhere, right? And then we have to run it on our infrastructure. So this is always need to remember, guys, when you want to use an open source model, you have to be very clear about how many billions of parameters this model is being trained, whether it is quantized model, or how much bit quantization is there for that model itself. Based on that, you will be deciding your GPU VRAM itself, because let's say you want to use GPU, right, A100, H100 or whatever it is, but how much VRAM it should be there for the GPU itself, right? If anything is not clear in this particular video, please mention out on the comment section. I'll try to make a separate video on top of that, right? So when I say quantization means the model has been somewhere quantized, or you can say kind of dimensionality reduction in your machine learning, right? It just reduced to a particular bytes so that your model can be compatible with the edge devices, right? So let's say llama model or mixed-all model has been quantized on a different scales like 1 bit, 4 bit, 8 bit, right? This is how. So let's say if I'm just giving you an example, like how can we calculate how much VRAM it would be needing, right? So let's this is a very good platform here. If I talk about this is a formula, right? They are mentioning everything. Is like how to deploy a llama 3.1 model, right? 3.2 vision model, right? Maybe you have heard of it. This is a multi-model thing. 3.2, 90 billion parameter, and I think 11 billion parameter model is has been there, right? And deploying it, everything is given, and this formula can be used to calculate the GPU memory, where M is your GPU memory expressed in gigabytes. Then P is what? P is the number of parameter that model is being trained. So if I talk about Mixed-all 7B, it has been trained on the 7 billion parameter, right? So different parameters are there. If I give you an overview about the open source models, open source LLMs, so if you see here, right, these are the parameters, right? So if I talk about T5, it has been trained on this 0.06 to 11, or Bloom, or Chet GLM, or Dolly, which is from the Databricks, I think, right? And MPT, Open Llama, Falcon. Falcon is huge model, right? Falcon is very good model as well. So it is present on the 7 billion parameter also, 40 billion parameter also, and 180 billion parameter also. So whatever you need, you can go ahead and use it, right? So let's say I want to calculate for Mixed-all 7B. Okay. So P value will be 7 and B. So 32 is there, like P into 4B by 32 by Q. 32 is nothing. It's a 32 bits. Okay. 32 bits. And Q is the amount of bits that should be used for loading the model. Means you are using 4-bit quantization, 6-bit quantization, 8-bit, that is up to that. So Q I can take as a 4 or as a 8, anything, whatever is there, like 16, anything like that. 1.2 is a representative 20% overhead of loading additional things in GPU memory. It's a additional, they are adding it, right? So this additional libraries you are using and accelerate and all, right? So in that case, so if you use, let's say 70 billion parameter, llama 70 billion parameter, so P will be 70, 4-bit, okay, and 32 by 16, and because of I'm using 16-bit quantized model right here, so 70 and into 1.2. So you can see here 168 GB of VRAM needed to deploy this particular llama 70 billion parameter model on your local and open source itself, right? I hope you understood this part, right? At least two A100 GPU needed to deploy and use this model as your local model itself, right? So this is all for this particular video, guys. Please go ahead and like this particular video and subscribe to our YouTube channel. And please stay tuned. We are going to, in the next particular video, we are going to majorly talk about the code part. How can we use these LLM models and an API? And in some videos, we'll be talking about the deployment of open source model as well. So thank you.